So welcome to this section on triggers. We're going to have a look at what triggers are and how to write them. So we start right away with an example in the context of our traffic example where we had the two green lights that we are controlling and two cars that are coming from the environment. So we have the basically sensors where there's a car and we can give green lights on both lanes. And the lanes should never have the green lights together because otherwise that's a crash. And now here, so this is already, we had already seen many times in these examples. Now here, there's a new guarantee, and this guarantee now is a trigger. And a trigger has two sides. It has a left side, this would be this one, and it has a right side. This would be this one. And the left and right side are both regular expressions. So triggers have two regular expressions separated by this trigger operator. And they always have to start with the keyword trig, and they can be guarantees or assumptions. Now this one is a guarantee, and this one is a regular expression. So in the regular expression, we still need to talk about what do these regular expressions go over? They go over sequences of states. Now, a state is some assignment to variables, as we know it, and these variables are the variables, of course, from the specification. So here we have a very, very simple constraint, which is the true constraint. So basically, it doesn't constrain any assignment to any variables. All assignments are fine. And now what we have in these square brackets, that is describing one state. So everything inside square brackets is one state. So true is one state. Then we have here another set of square brackets. We have car A and not green A. That's another set of states, all the states that satisfy car A and not green A. So basically there's a car waiting and it doesn't have a green light. Then there are some operators. So here, for example, the star, that's the cleany star. Then just writing one element after the other, that's concatenation. So here we have true star, and then we concatenate car A and not green A. And now this one is the repetition operator. So this one is iterated or repeated 4 times. So this means that this trigger, basically the left side is satisfied. Yeah, whenever something might have happened, we don't care what, then there has been a car A and the green light for lane A has not been on for 4 times. This would make the left side of this trigger be satisfied. And the constraint induced by the trigger is that then the right side has to be satisfied. The right side we see is a single state where green A is true. So what will happen is during the execution, whenever the left side is satisfied, the trigger will basically track, has the left side been satisfied? If so, then in the next state, the regular expression on the right side has to be satisfied. So now here it's a single state. It's not really a sequence, but it could be because it's again a regular expression. So then after we haven't seen a green light, but a car has been waiting, we will then see a green light. And then we go back to tracking the left side. So once the right side has been satisfied, we go back to tracking the left side. This is one example trigger. Now you might wonder what are the regular expressions that we can use. And there are some operators. They are also described in the user guide. So we have this concatenation, we have the union, we have intersection. Now intersection, of course, this operator might look very similar to another operator, the one for conjunction. That's just because they are in regular expressions used like that. So here we have the intersection, and then here we have the conjunction because this one is inside the square bracket. So this is describing some expression over variables, describing a set of states. And this one is actually describing an intersection between regular expressions. So if it's outside the square brackets, then it's the one for regular expressions, the end, which is the intersection, and inside it's the normal, meaning as everywhere else in expressions of spectra. Then, of course, the repetition multiple times, at least once, optional. We have this iteration, exact repetitions, where you have to repeat it exact k times. Then we have the at least repetitions if there's in the curly brackets the k and then a comma, and so on range. We have negation in regular expressions. That's this tilde sign. So these are the operators we can use for the regular expressions inside the triggers. And now we can add another trigger. So there are some, let's say, maybe a bit non-standard triggers that we could add. So for example, what you could do with triggers is you could add something that does not allow two green lights to exist at the same time, right? We have this written here, but now let's maybe try to rewrite this guarantee as a trigger. Now, we don't really care what happened before, so we have again this true star. Then we need a state where the green lights are both on, and this could trigger some other regular expression. Now, which one should we trigger? Well, let's try to put false. This basically means that this right side should never happen because there's no way to satisfy the right side. So the semantics of the trigger are whenever the left side is satisfied, the system or the one who has here it's a guarantee. So the system will switch to the right side and try to satisfy the right side. And once it's done there, it goes back to monitor the left side. But here, there's no way to satisfy this false. So now what the system will do is it will have to prevent this state from ever happening. And of course, it can do that because that's very similar to the specification we had before. And yeah, it's again realizable. The controller will be a little bit bigger because here we need, well, to count to 4. But there are some other things, yeah, we might express. So maybe a more interesting one. Let's try to also write an assumption to see that triggers also work in assumptions. So in assumptions, very similar. We could write an assumption with a trigger. And then maybe we can now say that if a car A comes, again, we don't care after what time. So we do, again, a true star, which means other things can happen before this car A comes. But then once this car A comes, we are basically moving to the right side. And then we could say there, we don't care what happens for 0 up to 3 times, but then afterwards, we are going to see a car B. So that's now an assumption that every car A will then be followed within 0 or 3 steps by car B. And they don't, so this is really after the right side is satisfied, after we had a state that satisfies car A, then we can move over here and car B could immediately come afterwards because there's this 0 here. But car A and car B, they would not be captured if they would appear together. Then again, still after this 0 to 3 steps, car B would have to appear again. Because of course, if car A and B appear together, it would only like satisfy this left side here. And then of course, well, if they appear afterwards together again, then of course it also satisfies the right side. So this would be some examples of triggers. Now the task here would be to extend the specification GridL4. So that's again the robot moving on the grid. And now a guarantee should be added that the robot should never be away from position P1 for more than 20 steps. And these positions, they are shown here. So P1 is simply when this is the predicate 0, 0. So you could imagine some trigger written here that guarantees that the robot never moves away from that position P1 for more than 20 steps in a row.